Salt marshes are super inspiring to me. They're at a place where the ocean meets the land, and they're just very unique environments.
The beauty of the salt marsh just draws me in, and I really want to understand it from many different perspectives.
There's so many different factors at play in the landscape of the marsh. It's really fun to play a role in putting the puzzle together.
They're very important for wildlife. They reduce storm surge, and they capture pollutants. And on top of all of that, they capture carbon at rates much higher than environments like forests and other terrestrial environments.
This is an ecosystem that if we protected, it could help us fight climate change.
Greenhouse gases are gases in the atmosphere that are present in very, very small concentrations, but they have a very powerful effect on the temperature of the planet. They're very effective at trapping energy as it's radiated off of the Earth. And so the more greenhouse gases we have in the atmosphere, the more energy we have that is trapped against the Earth and in the atmosphere. And that results in major changes to the climate. And the plants that are growing on the salt marsh are very effective at converting carbon dioxide, which is a greenhouse gas, into the plant material and into the soils. Terms that are used to describe this process are carbon sequestration and carbon capture. The tides are so important to salt marshes because they bring sediment up to the marshes, and they bring material needed for the marshes to keep growing in step with sea level rise. The tides come in and come out twice a day. And when that water comes in, it flows in through the tidal channels, it flows into the marsh sediments. And then when the tides go out, the tidal channel drains and the sediments drain as well. But the sediments are always waterlogged. And what that means is there's very little oxygen in the subsurface. And because there's very little oxygen in the salt marsh soils, the carbon that gets buried is well preserved, and it's preserved through time. And wouldn't it be great if all salt marshes were healthy and storing and sequestering carbon as well as they could? It turns out they're not. So there are some things that make salt marshes change from being a carbon capturer to starting to emit greenhouse gases. And those are things that limit tidal flow.
They're called tidal restrictions. So things like roads and railroads or dams can often result in pretty unhealthy marsh conditions upstream of the tidal restriction.
The movement of water across the marsh can be also influenced by the historical uses that were put into place by the earliest farmers in the area. They do that by reducing the amount of sediment that gets onto the marsh. They also can lead to more water standing on the marsh that kills the vegetation and can convert different vegetation types and make the marsh vegetation start to degrade over time. In many cases upstream of a tidal restriction, the carbon movement can be out of a salt marsh instead of into it. And so our work with the Maine Sea Grant is trying to put some numbers on those changes in carbon dynamics upstream and downstream of the tidal restrictions. We're working in 4 marshes, and we're looking at short-term carbon dioxide and methane movement into and out of the sediments. And we're also collecting sediment cores. We can look at longer-term carbon sequestration over decades, centuries, and millennia. Coastal managers can use these data to determine and prioritize which systems they would like to restore. So the data that we are providing from this study will be helpful in thinking about the carbon benefits that come about from restoration of salt marshes. I feel very optimistic about the state of salt marshes. That's not to say there aren't a lot of challenges ahead for us, but I think we can make some good progress in restoring salt marshes to their original health and improving the health of the coastal zone and decreasing CO2 in the atmosphere.